Before I begin my end-to-end courses on data science and AI engineering, I wanted to give you a quick teaser about where we truly stand with LLMs today. All right, let's get started. ChatGPT can write poetry, code entire applications, and pass the bar exam. So it's intelligent, right? Well, not so fast. What if I told you that the same AI that can explain quantum physics can't figure out a simple block stacking puzzle if you just change a few words? That is more like a really sophisticated parrot than a thinking machine. Today, we're diving deep into one of the most controversial questions in AI. Are large language models actually intelligent? And trust me, the answer is way more nuanced than you think.
Before we can judge whether LLMs are intelligent, we need to ask a more fundamental question. What is intelligence in the first place? Is it the ability to store information? A dictionary can do that. Is it the ability to calculate? Your calculator does that faster than any human. Is it creativity? Well, a random number generator creates things that have never existed before. Here's where it gets interesting. François Chollet, the creator of Keras and the ARC benchmark, gives us a definition that cuts through the noise. Intelligence is not about what you know. It's about how quickly you can learn something new. Think about it. A human child can see 3 examples of a simple pattern and figure out the rule. They can then apply that rule to completely new situations they've never seen before. That's intelligence. Skill acquisition efficiency. The ability to efficiently adapt to novel situations with minimal data. Now, contrast that with something else. Skill itself. A chess engine that has memorized 1 billion games isn't intelligent in this sense. It's skilled. It has crystallized intelligence, a massive library of patterns. But if you change the rules slightly, create quantum chess or 5D chess, it's back to square one. And here's the kicker. Humans aren't the only intelligent creatures. Crows can solve multi-step puzzles they've never seen before. Octopuses can learn to open jars by watching just once. Even your dog figures out new ways to steal food from the counter. Intelligence isn't about being human. It's about adaptation. So the question becomes, can LLMs adapt to truly novel situations, or are they just incredibly sophisticated memory banks?
Let's talk about what LLMs actually do. And to understand this, imagine you're learning to play chess. One approach, you memorize thousands of game positions. When you see a board state, you recall, I've seen something like this before, and play the move that worked then. You're matching patterns. Another approach, you understand the principles. You know that controlling the center gives you mobility. You know that a bishop and knight can checkmate a lone king. You can reason through a position you've never seen before by applying these principles. The first approach gets you pretty far. You might even beat decent players. But put you in a situation that's truly novel, change just one rule of chess, and you're lost. You never understood the why, only the what. LLMs are the first player, every single time. Professor Subbarao Kambhampati from Arizona State University describes LLMs as n-gram models on steroids. They're essentially performing approximate retrieval. They're searching through a compressed representation of all the text they've ever seen and finding the most statistically likely continuation. Think of them as the world's most sophisticated autocomplete. They have a model of how words are distributed in text, not a model of how the world actually works. And here's where the illusion happens. We humans find grammar and style incredibly hard to master. Learning a new language takes years, but once we know the language, expressing our thoughts is relatively easy. LLMs are the exact opposite. They've mastered style to perfection. They rarely make grammatical errors. They sound fluent, confident, articulate, and that tricks our brains into thinking there's understanding behind those words. But there's not. It's all style, no substance.
Want proof? Let me show you one of the most devastating experiments that exposes what LLMs really are. Researchers gave LLMs a simple planning task: stack blocks in a specific order. Things like put block A on block B, then put block C on top. When they used standard terminology like stack, unstack, put on, the LLM did great. It generated perfect plans. Then they changed one thing, just one thing. They kept the exact same logic, the exact same rules, but swapped the words. Instead of stack, they used feast. Instead of unstack, they used unfeast. Think about that. The logical structure was identical. The problem was identical. Only the words changed. A true reasoner would see through that instantly. The logic is the logic, regardless of what you call it. But the LLM couldn't, because it wasn't reasoning, it was pattern matching. It had seen stack and block together thousands of times in its training data. It had never seen feast used that way. This is what François Chollet calls the difference between interpolation and extrapolation. LLMs can interpolate, they can find answers that exist somewhere in the space of their training data, but they cannot extrapolate to truly novel situations that fall outside that distribution.
Now, here's where I'm going to push back against the haters, because there's a narrative that says LLMs are just dumb stochastic parrots. They're worthless. That's wrong, and it's dangerously wrong. On a scale of 0 to 10, where 0 is a rock and 10 is human-level general intelligence, LLMs aren't a 0. They're not even a 2. They're probably somewhere around a 4 or 5. And that's extraordinary. Think about what they can do. They can take your jumbled thoughts and organize them into coherent arguments. They can spot patterns across millions of documents that no human could ever read. They can make creative connections between ideas from completely different domains. They can generate code, debug it, and even explain what it does. Professor Kambhampati actually calls them creativity engines. They have shallow knowledge of essentially the entire internet, which means they can make inductive leaps and generate novel combinations of ideas. The problem isn't that they're useless. The problem is that we're using them wrong. We're asking them to be both the generator and the verifier. We're asking them to come up with answers and tell us if those answers are correct. That's like asking a student to grade their own exam. Research shows that when LLMs are asked to critique their own solutions, their accuracy often drops. They hallucinate errors that aren't there or miss real ones. They can't verify because verification requires actual reasoning, not pattern matching.
Let's go deeper into what François Chollet means by the difference between skill and intelligence. An LLM that can write Python code has skill in Python, but does it understand programming? Here's a test. Can it learn a completely new programming language from just a few examples? Not one that's similar to Python, but one with fundamentally different paradigms. A human programmer can. Show a skilled developer a few examples of Haskell or Prolog, and they'll start to grasp the underlying principles. They'll extract the abstract rules. Oh, this is functional programming, or this is logic-based programming. LLMs struggle with this because they don't have the meta skill of learning new skills efficiently. They have millions of examples of Python in their training data. They've memorized millions of vector functions, as Chollet puts it. But intelligence isn't about having memorized solutions. It's about being able to synthesize new solutions from first principles. Here's Chollet's beautiful metaphor, the kaleidoscope hypothesis. The world seems infinitely complex, but it's actually generated by repetition and composition of a few simple atoms of meaning. Intelligence is the ability to mine experience to identify these reusable abstractions and recombine them.
Children do this naturally. They see a few examples of addition and extract the principle. Then they apply it to dollars, apples, toys, abstract numbers. The abstraction transfers. LLMs don't extract abstractions this way. They memorize correlations. They know that in contexts that look like X, the answer tends to look like Y, but they don't know why.
So if LLMs aren't intelligent in the way we thought, does that mean AGI is impossible? Not at all. But it means we need a different approach. Both Kambhampati and Chollet point to a similar solution, and it's fascinating that they arrived at it independently. Kambhampati calls it LLM modulo. Chollet calls it System 1 plus System 2 hybrid architecture. Both are saying the same thing. We need to combine the pattern-matching power of neural networks with the discrete reasoning of symbolic systems. Here's how LLM modulo works. Step 1. Generate. Let the LLM do what it does best. Generate ideas, brainstorm solutions, write code, create plans. Use it as a creativity engine. Step 2. Verify. Use an external, rigorous tool to check the work. For code, that's a Python interpreter or a compiler. For logic, that's a theorem prover. For planning, that's a formal planner. For factual claims, that's a search engine or database. Step 3. Refine. When the verifier finds an error, it sends a specific error message back to the LLM. The LLM generates a new attempt. Repeat until verification succeeds. This isn't the LLM becoming intelligent. This is us using the LLM intelligently. Chollet takes this further with his System 1 or System 2 framework. Humans use fast, intuitive pattern recognition, System 1, to prune the massive space of possible solutions. Then we use slow, deliberate, step-by-step reasoning, System 2, to verify and work through the details. Current LLMs are pure System 1. They need to be paired with System 2 capabilities, discrete program synthesis, logical reasoning, causal modeling. The recent progress on the ARC benchmark is exciting because it's exactly this: hybrid systems that use deep learning to guide discrete program search. Neural networks suggest which programs might work, and symbolic systems verify them.
You might be thinking, okay, cool, but why should I care about this philosophical distinction? Because the difference between thinking LLMs are intelligent and understanding what they actually are determines how we use them. And using them wrong can be dangerous. If you think ChatGPT is reasoning, you'll trust it to make important decisions. You'll trust it to write critical code without testing. You'll trust it to give medical advice. You'll trust its legal interpretations. But if you understand it's an approximate retrieval system, an incredibly powerful one, but fundamentally a pattern matcher, then you'll use it appropriately. You'll use it to generate first drafts, not final answers. You'll use it to explore possibilities, not determine truth. You'll verify everything it produces. Professor Kambhampati is critical of papers claiming sparks of AGI based on cherry-picked successes. He advocates for what he calls diagonalization, stress testing models to find where they fail, not just celebrating where they succeed. Because in the AI field right now, there's enormous pressure to hype, to exaggerate, to claim we're closer to AGI than we really are. And that's not just misleading, it's actively harmful to real scientific progress. So, are LLMs intelligent? The answer is yes and no. Or rather, they're intelligent in some ways and fundamentally limited in others. They're intelligent in the sense that they can perform complex pattern matching, generate creative combinations, and produce human-like text. They're not zero. They're remarkable tools. But they're not intelligent in the sense of being able to reason from first principles, adapt efficiently to truly novel situations, or verify their own outputs. They're not understanding, they're retrieving. And honestly, that's okay. We don't need to claim there's something they're not. A hammer doesn't need to be a screwdriver to be useful. It just needs to be a really good hammer. The path to AGI isn't about making LLMs bigger. It's about recognizing their strengths and limitations and building hybrid architectures that combine neural intuition with symbolic reasoning. It's about, as Chollet beautifully puts it, teaching machines to extract the atoms of meaning from experience and recombine them in novel ways. True program synthesis. We're not there yet, but understanding what we have and what we don't have is the first step. If you found this video valuable, consider subscribing. Drop a comment below. Do you think LLMs are intelligent? Where would you place them on that 0 to 10 scale? Let's discuss. Until next time, stay curious, stay skeptical, and keep questioning the hype. Don't forget to subscribe. The end-to-end course launches shortly, and we'll keep bringing you enjoyable, easy-to-learn AI videos just like this.